In this lecture, we are going to study about the application of Minitab for binomial distribution. Now, binomial distribution, as you know, bi means two, as in case of bicycle. So, binomial distribution talks about the two outcomes, whether it is success or failure, or defects or no defects, head or tail, etc. So, there are basically two outcomes in a binomial distribution. And the probability of the success or failure in the binomial distribution is always the same. For example, if you toss the coin, then the probability of occurrence of the head is 50% and tail is 50%. So if you repeat a tossing coin for number of times, it follows the binomial distribution. Now in this example, we are going to study about the binomial distribution with an example. In 2019, the on-time arrivals of all the Delta Airways flight was 91%. Mr. Kim, who was the air traffic controller, wants to find out the probability that in next 10 flights, 7 flights will be on time. There are 3 scenarios. He wants to find out whether in the next 10 flights, 7 flights will be on time, or all flights will be on time, or at least 8 of the 10 flights will be on time. First of all, we should check if this is a binomial distribution or not. The experiment should consist n identical trials for a binomial distribution. Yes, the trials are identical. We are talking about the success or failure of the plane landing in time. Each trial should result in one of the two outcomes called success and failure. In our case, the success is plane landing on time and the failure is the plane not landing on time. Now another parameter is the probability of success denoted by P remains the same from trial to trial. As we have a year-long data that the probability of a success or a probability of a plane landing on time is 91%. In this case, we have a historical data of 2019 where the probability of success was 91% or 0.91 and we assume that it remains the same, and we know that these trials are independent to each other. Here, the time taken by one flight in landing is not affected by the time taken by another flight in landing. One thing to understand is binomial distribution is also called the discrete distribution. It is not continuous as in case of a normal distribution. It has only two outcomes, whether it is success or failure, head or tail, slow or fast, etc. The first problem that we have to solve is finding out the probability that in next 10 flights, 7 flights will be on time. Now I will show you solving this problem with two approaches with Minitab. The first approach, you go to the graph, click the graph and click the probability distribution plot and select the view single. We click the OK. Now this distribution is a binomial distribution. We should select the binomial and we know that number of trial is 10 because Mr. Kim wants to find out the probability in next 10 flights. So the trial is 10 and the event probability is 0.91 because on time arrivals of all the Delta Air flight was 91%. So we assume that the event probability is the same this year too, and we click on the OK. As soon as we click OK, we see a binomial distribution plot. So the problem was finding out the probability of landing of 7 flights in time. We click on the 7 and in this box we see that the probability is 0.045. So the probability of landing 7 planes on time is 0.045 or 4.5%. Another question was probability of landing all the flights in time. All the flights means 10 out of 10 are landing in time. So we go here where the n is 10 and x is also 10. Probability of px equals 10 is 0.389. Now I want to show you another method of finding the binomial distribution. Here the binomial probability for landing of 7 planes in time was 0.045. Let us see another method. I will use calculator this time. So I go to the calc and I go to the probability distribution, click the binomial distribution. I'm choosing probability for 10 number of trials. Event probability is 0.91 and the input constant is 7 because we want to find out the probability for 7 number of planes landing on time. And then we click the OK button. As soon as we click the OK button, we see that the probability of landing 7 planes in time is 0.045, which was the same as we saw from the graph earlier. So now we have the probability for 7 flights landing on time, and all flights are 10 out of 10 flights landing on time. Now the next question is at least 8 flights landing on time. For that, I will add up a second approach. And now this is rather interesting because probability of landing of 8 flights means probability of landing of 8, 9 or 10 flights. So I go to the graph, click the probability distribution, and now I will add up a slightly different approach. I will click the view probability and click the OK button. Now you have to select the binomial distribution over here. The number of trial is 10 as earlier. Event probability is 0.91, and I go to the shaded area. Make sure that you click the X value instead of the probability when you are running this window, because clearly we know the X value. We want to find out the probability of at least 8 flights landing on time. The question is a right tail probability distribution because we want to find out the probability of 8, 9 or 10 flights. If our question was probability of not more than 2 or 3 flights landing on time, and then we should have selected the left tail probability. This is a right tail probability because we are trying to find out at least 8 flights out of 10 landing on time. Now, if our question was a little different, for example, if we want to find out the probability of landing of 4 to 8 flights on time, then you should have selected the middle one. Now let's leave the explanation. I will select the right tail and click the OK button. Now you see a distribution plot again. The probability of landing of at least 8 flights. There is a 94.6% of probability that at least 8 flights will land on the time. So summarizing, the probability of landing of 7 flights in time was 0.04 or 4.5%. The probability of landing all the flights in time was 0.389. And the probability of landing at least 8 flights in time is 0.946.